In the last period, we have to discuss one of the two theories of reaction rates is collision theory. Now, this time we will discuss about the second theory of reaction rate, that is activated complex theory or transition state theory or theory of absolute reaction rate. This is more sophisticated theory of reaction rate that can be applied to reactions taking place in solution as well as in gas phase. Before we proceed, we see the energy profile diagram, reaction profile diagram like this. You must remember this diagram carefully because all the explanation is related to this diagram. On x-axis there is reaction coordinate, on y-axis there is a potential energy. Now look at this curve, that is like this and like this. Here at this point, this is the potential, here the reactants, and at this point it is the product. The potential energy of this reactant is denoted as E1. The potential energy of product is denoted as E2. And in this case or in this curve, this is the state of activated complex. And I can write like this: activated complex or transition state. Activated complex or transition state. Can write this in short. Now, according to this theory, before the reacting molecules changes into products, before the reacting molecules means reactants changes into products, they form an intermediate called as the activated complex. This activated complex has higher energy than both the reactants and products. For higher energy, it is or due to which it is unstable and has very short lifetime or very short existence. Means activated, the state of activated complex, the life of it is very short lifetime of activated complex. For this reason, this theory is called as activated complex theory or transition state theory. In this case, transition state or activated complex is formed. The reason behind it, and that the energy of this is high, it is highly unstable and very short lifetime. Therefore, this theory is called as activated complex theory or transition state theory. In this theory, as two reactants approach each other, therefore potential energy increases, reaches to maximum. We look at this: potential energy increases, reaches to maximum, and this maximum corresponds to the activated complex. This activated complex decomposes at a definite rate to form the products, and potential energy drops to E2. Means in this case or in this diagram, E1 is the potential energy of the reactant or reactant molecules. E2 is the potential energy of the products. And here the difference between potential energy of the reactants and activated complex is called the energy of activation. Now consider the reaction X plus YZ gives XY plus Z. Now look at the three steps. First one is, in general we have to say earlier, in this case first step, in the initial state, X and YZ molecules are far away from each other. Therefore, reactants means X plus YZ. Product means XY plus Z. And in this case, in the first stage or in the initial state, X and YZ molecules are far away from each other and potential energy of the reactants is unaffected. When X approaches YZ, potential energy of the reactants increases, reaches to maximum, and this maximum corresponds to the activated complex. Activated complex in this case is X dash Y or dash Z, or we can show like the dotted lines. Dotted lines means indicates it has high energy, due to which it is unstable and very short lifetime. Therefore, it can be shown like this dotted line. It is highly unstable. This complex decomposes at a definite rate to form the products with energy E2, form the products, and potential energy drops to E2. Therefore, this diagram is very important whenever we can explain this theory. The difference between potential energy of the reactants and activated complex is called the activation energy or energy of activation of the reaction. This energy must be added. This energy must be added to the molecules in order to get them react. And this energy is supplied by conversion of some of the molecules, some of the kinetic energy of the molecules into potential energy. At higher temperature, more molecules get over this potential energy barrier in unit time and the reaction can occur. So in this way we can explain the transition state theory or activated complex theory. The major difference between the collision theory and transition state theory is that in collision theory it does not form, or before going the reactive molecules into products, we does not form the activated complex in the collision theory. Simply molecules collapse with sufficient energy, and that sufficient energy or minimum energy is called as energy of activation. In collision theory, minimum energy required for the collision between molecules to be effected is called as energy of activation collision theory. In this case, these reactant molecules before going to products form the activated complex. So only thing is that in this theory there is no activated complex, and in this theory there is activated complex. So from these two theories we can explain the theories of reaction rates. Thank you.